Ladies and gentlemen, a very good evening, and I warmly welcome you to the fifth workshop of the Battery Technology and Charging Infrastructure for Electric Vehicles, a workshop series organized by IEEE Y2N Pro. I'm Manusha Jailat, your host for the day. To give a brief overview of this workshop series, this is a comprehensive course that offers both theoretical and practical insights into battery technologies and recharging infrastructures of the electric vehicles. This series addresses the surging demand for expertise in the EV sector, focusing on battery system and charging infrastructure. You will be able to explore the evolution, operational principles, and future advancements of EVs, delving into battery technologies and innovations aimed at enhancing efficiency and safety. Today's workshop focuses on the EV battery supply chain, the challenges, and ensuring sustainability. Before moving on, we have some important announcements to make. We have already shared these guidelines to be followed during the workshop series. However, I will read the guidelines and make sure that you follow them for a smooth session. A quiz would be administered at the end of the workshop series on the 5th of October, where you would be assessed on the knowledge gained. The IEEE credential certificate will be awarded only if you achieve at least 80% on the above mentioned quiz and attend at least 80% of the sessions. Attendance will be marked at 3 given instances of the session. Therefore, please be present throughout the session. The recording of the webinar will be uploaded to the Google Classroom. Please rename yourself using the registration number provided in the handbook and your name if you haven't done so already. Today, we honor to have a distinguished academic with us who will guide you through the EV battery supply chain, the challenges of ensuring sustainability. Thank you, sir, for accepting our invitation and joining us today to deliver the speech. Professor Niles Perera, based at the University of Moratuwa, specializes in transport and logistics management. His research focuses on supply chain management, behavioral operations, forecasting, logistics, and system dynamics. With a PhD from the University of Sydney and a BSc from the University of Moratuwa, he actively contributes to IEEE and Sri Lanka Society of Transport and Logistics. Professor Perera is recognized with awards, including the Senate Research Committee Award for Outstanding Research with Distinction and Teaching Excellence Award, underscoring his significant contribution to academia and research leadership. Professor Perera's commitment to advancing sustainable logistics practices and his leadership in academia underscore his influential role in shaping future supply chain strategies. So, ladies and gentlemen, please welcome Professor Niles Perera to deliver the keynote speech on the EV battery supply chain, the challenges of ensuring sustainability. The spotlight is yours, sir.
Thank you very much, Anusha. Thank you very much for the organizing committee also from IEEE Y2N Pro for inviting me for this particular session. So let me get the slides up and running. I hope they are visible. It seems they are.
Yes, we are.
Fantastic. Thank you. Thank you. So basically, what I'll be talking about today would not really go into the details of the technology. That's not my expertise. But I'll be mostly talking about the entire supply chain from a superficial level. Because right now in the world, there's a little bit of a challenge with respect to how to expedite the transition into electric vehicles. While everyone seems to be accepting that this transition needs to happen, there are certain arguments with respect to the timeline, whereas certain organizations, countries are very keen to make that transition seamless and very quick. There are also certain challenges that are circumventing that progress. So my discussion, my presentation today will mostly dive into the supply chain challenges that are there. I will, at the end of the presentation, share some insights on opportunities that are available to Sri Lanka as well. At the same time, I will basically give you some of the major geopolitical issues that are intervening on the development of the electric vehicle battery supply chain, as well as the progression of electric vehicle ownership and embracing this new technology. So I don't know, it might be a little different to the previous sessions and perhaps the next upcoming sessions, but my perspective is to give you a very broader perspective from a bird's eye viewpoint into the challenges, especially from a supply chain perspective, since that is my expertise. So you might be aware already that different OEMs as well as countries have adopted different targets with respect to electric vehicle adoption. In certain instances, these are driven by natural reasons in the sense the climate change and so on. The Paris Climate Agreement has enforced certain entities to take certain measures. And on the other side, there are regulatory actions also. For instance, the European Union took a conscious decision that they need to stop electric vehicle, ICE manufacturing, internal combustion engine manufacturing by 2035. So as a result of that, all the European manufacturers have embraced that, and some of the countries have essentially set targets on when they are going to achieve it. And in other cases, for instance, in the case of China, China has a very interesting scenario. I will talk about China a little more. Probably about 15, 20 years ago, China, even before Paris Climate Accord and even before, well, climate change was a topic back then too, but not to the same gravity as it is today. Then China took a decision to funnel in money for EV technology. One of the reasons was they were having a very large fuel bill. A considerable amount of their imports were actually for fuel. So this was a big problem for China's economic growth. And at the same time, China had very polluted cities. This was very highly exacerbated during the Beijing Olympics of 2008, when there was a lot of pollution and a lot of backlash about the environmental conditions of China. So during that time, the Chinese government, especially a very foresighted Minister of Science and Technology, took that decision to support EV adoption in China. And right now, we see a massive focus in China towards EVs. So the adoption targets and the adoption levels and the overall roadmap has been guided by various factors. In certain instances, it has been pushed by particular environmental factors. In certain instances, it has been led by regulatory forces or political leadership. But one way or the other, I think what seems to be quite evident is we are seeing that trajectory. We are seeing that sort of a movement towards EV adoption. And even in Sri Lanka, over the last couple of years, only EV vehicles were allowed to be imported to Sri Lanka under a special scheme. And I know for a fact there's a possibility that in the future also there would be more and more opportunities given to import EVs as opposed to ICE vehicles. So the trajectory seems to be moving towards EV adoption, or at least looking at not just electric vehicles, but maybe other new energy sources that will fuel transportation. So what we see is quite straightforward. It seems that EVs are becoming more and more popular, but it is not without its challenges as well. But before we talk about the challenges, I think one of the interesting things we need to understand is if you take the world's share of EV sales, China is leading. Roughly about 50% of the EV sales in the world is actually in China. That is followed by Germany, United States, France, UK, and so on. So this is very interesting. And I would explain why this is interesting also in the next slide. But it seems that there is a little bit of a focus on China in terms of how they have become a powerhouse in electric mobility. But at the same time, if you look at the percentage of vehicles bought, like if you sell 100 vehicles in a particular country, what is the percentage of electric vehicles out of that 100? Norway is leading. This is actually data from 2018, so a little historic. But if you look at this particular graph, you can see Norway has set a very ambitious target of being fully electric by 2025. So because of that, Norway has a very high rate of electric vehicles purchased within their country, whereas in other countries, there are certain lapses. So if you take the United States, one of the largest vehicularized societies in the world, the rates are not that good. And over the last several years, some of the manufacturers have been struggling. One of the classic examples is Ford. Ford has struggled to continue their EV production, and they have cut back on production because the prices of EVs in US is much higher compared to gasoline-based vehicles in the US. So the problem is we have two sides to the coin. We have a case where it seems inevitable that electric mobility will take charge of transportation in the world. But at the same time, we are seeing another perspective where consumers, if they are not given that advantage, are unwilling to purchase electric vehicles. So there's a little bit of a dichotomy there. So what is the real underlying case? The underlying case is the electric battery, the EV battery that is there. So majority of the batteries that are used are lithium ion based batteries, you know that. But there are new technologies that are coming up like LFPs, blade batteries. You would have learned about that in previous workshops. But the problem here is that roughly about 40% of the cost of an electric vehicle actually comes from the battery. Now, this is very significant. Now, naturally, if you take a ICE based car, if you take an internal combustion engine based car, it has roughly about 15 to 30,000, 40,000 different components, small components, right? But if you take an electric car, it doesn't have that many components. The number of components are very limited. In fact, there are probably about 15 to 20 moving components in an electric vehicle. So when you really look into it, the electric vehicle is less complex compared to a ICE vehicle. And when you say that it's less compared, that might imply that it should be cheaper, but it's not always the case. And the primary reason for that is roughly about 40% of the cost of an EV goes into the battery. And the battery is full of critical minerals, CMs. And these minerals are scattered across the world. And there are not many companies that are capable of first you need to mine the minerals, then you need to refine and process the minerals, and then you need to make the batteries. And that technology for the entire supply chain is not available for all the organizations. So this is one of the challenges that is ailing the progression of EV adoption around the world. Now, around the world, you see subsidies being given for EV purchasing. Even in Sri Lanka, that is the case. So the migrant worker scheme, if you are working outside of Sri Lanka, if you have money, you can remit that money, and against that remittance, you can purchase an electric vehicle for a duty concession. That is what Sri Lanka had until about few months ago, until this scheme was scrapped. So a lot of people use this to buy electric vehicles. If you take Germany, for example, Germany gives a massive tax credit for electric vehicle purchasing. This has been the case in the US also, where the Biden administration gives tariff concessions to anyone who's buying an EV, but there is a caveat to that, which I'll talk about later. So in most countries, the adoption into electric vehicles, brand new electric vehicles, has been pushed by the government, and it has often been through the mechanism of a duty concession, a tax concession, or something like that. And this is, I think, where the challenge is. How do we ensure that the ideal targets that have been set by different entities can be well met by ensuring that the customers, the car users, are able to purchase electric vehicles for a reasonable price? So this is where I think we need to understand how the supply chain can help. So you all know that an electric battery has different components. Primarily, it has an anode and a cathode. It has a separator. It has electrolytes, and there is a collector that is there. So this is uh, the sort of the composition of an electric battery. And but all of that is essentially working. I mean, all of that is driven by these critical minerals. Without those critical minerals, it's very difficult to ensure that the batteries are satisfied. Now, one of the biggest challenges that is in the world is that some of these critical minerals are not abundantly available, and some of these critical minerals are available in conflict zones, in very challenged parts of the world. And this is one of the major challenges that have made the price of electric vehicle batteries very high. And in some parts of the world, you have deposits of these minerals, but getting to them is not very easy as well. So one way or the other, there are certain challenges that have been really hampering the progression of EV battery development and bringing down that cost of EV batteries over time. So that is a big challenge that is there. And as a result of that, we are seeing major like trade wars that are also emerging around the world with respect to ensuring the ownership of these critical minerals, as well as with respect to the establishment of battery manufacture. So, the battery supply, the EV battery supply chain, or even the electric vehicle supply chain, has many different stakeholders. You might be very familiar with some of these brands. You might not be so familiar with some of these brands, but by now you should be very well aware about some of the big names. Cattle is obviously the biggest manufacturer in terms of EV batteries. BYD is the largest electric vehicle manufacturer around, and you might have seen some of these advertisements in Sri Lanka also, because they partnered with a Sri Lankan agent, a very renowned blue chip company in Sri Lanka. And eventually, when the market opens up, they are planning to send in, export BYD vehicles to Sri Lanka. So there are different entities, especially from Asia, that is emerging to be part of this supply chain and becoming very core players in the supply chain. And there are well-renowned historic brands, like if you take Bosch in Germany, or 3M of Germany, 3M of US. It's in Minnesota, originally from Minnesota, and various other companies like that, and some startups also from around the world, which have come into the picture. But the problem is that all of these different verticals have different requirements that are there, right? So, for instance, we primarily see the electric vehicle and the battery, but I told you earlier also, there's a big process that happens upstream in the supply chain, from the point of gathering raw materials, the critical minerals, to processing them, and to then getting it into the batteries, and after that in terms of charging, recycling, and so on. And one of the interesting things that has happened over the last decade or so is that majority of these processes upstream in the supply chain have been have actually changed. Initially, the EV battery supply chain was dominated by Japanese and Korean companies. But over the years, you can see some Korean brands like Samsung, LG Chem, and so on. But over the last 10 to 15 years, China's major push towards increasing the electric vehicle footprint in their country has meant that they have made major investments into extracting these critical minerals and processing these critical minerals. So even sometimes if it is extracted by a different entity, they have the technology and the capacity in terms of processing, refining these uh, minerals, especially in South China, where there is a lot of activity. And even in South China, this Fujian province is seemingly the hub of electric vehicle manufacturing and battery technology. So what they have done is basically they have created um, a, essentially, I can't say it's a monopoly, but they have essentially taken control of the entire supply chain because they have access to the mines, the raw materials, the critical minerals, the processing, the refining, and they have the best batteries. We all know about cattle. You have heard of how good they are in terms of developing technology. Uh, you might have heard about the LFP battery that they have. They are, gradually trying to shift to the lithium iron phosphate battery, uh, which is expected to make significant changes in terms of uh, how we view electric vehicles. You would have heard about BYD's blade batteries. Blade batteries would actually uh, reduce the space requirement and ensure that there can be longer propulsions that are there. So they have been at the forefront, and also Neo. If you haven't heard about Neo, you can probably Google it or watch some videos on YouTube. Neo has been competing with the likes of Tesla. Neo is, I mean, they try to position themselves as a luxury brand, which is in competition with Tesla. The difference in Neo is they have battery swapping technology. So in China, they have stations where you can go and swap the battery. So you have a battery, you go to a particular location, there would be a cafe, you just park your car within 10-15 minutes, they swap the battery, they replace your uh, used battery with a new battery, and within that time you can have a cup of coffee or a tea, maybe do something on your laptop or phone, and then by the time it's ready you can go. It's a sort of a subscription based policy. And China, what they did was, because they identified this problem long before, they gave a lot of credits and opportunities um, for the user. So if you're a user of electric vehicles, you got preferential parking, you got rebates, you got actually a green color registration plate. Well, in some other countries also you see that, in Austria and in Germany and so on, you can see that. But they gave some sort of a additional recognition, and it was not just the number plate, but they gave a lot of other tax concessions and things like that. And for companies that are based out of US, like GM, Tesla, and so on, in order for them to come into the Chinese market, which is the largest, well, it used to be the largest market in the world until India overtook it. But to enter that Chinese market, they had to make sure that they had certain number of value addition happening within China. So, for example, uh, if if Elon Musk was to sell Tesla in China, where there's a large market, those who have been to China would remember that there are lots of Teslas on the ground, but they would have to do a lot of manufacturing and some of these value additions in China. So China has actually taken control of the EV supply chain more or less, and I think the reality is that given that insatiable appetite for vehicles in China, and given that there's a large swing in terms of demand, so by March 2024, out of um, out of majority of the electric vehicles sold, out of out of the vehicles sold in China, majority of them are now becoming electric vehicles. So consumers in China are having a major appetite for uh, electric vehicles. So as a result, they are not in a position to expedite and look at other markets at the same rate they would want. Number one, and number two, they are very protective of their technology to a certain extent, because they have developed those technologies and they have the patents and various accesses to across the supply chain. Now, this is why a lot of other countries are a little concerned about the dominance of China, and especially in the US, you see a lot of pushback against China in terms of their electric vehicles that are manufactured in China, or even the batteries that are manufactured in China. So the supply chain essentially um, covers the entire gamut from mining to end use. So you have to mine for these minerals. Lithium is obviously the most important part of it, but it's not just that. You need carbon for the anode, you need um, cobalt, nickel, magnesium, and so on for the cathode. You need copper for the collectors. Aluminium is there. So many different minerals are required. They need to be refined in a particular manner. The battery cells need to be made, and then they have to be put together to make the battery pack. And also the big challenge that a lot of people have not really addressed is what happens at the point of end of life cycle. Do you recycle it? Do you reuse it? Do you dump it into the environment? What is the output? I mean, there are various solutions out there, but there's obviously some sort of different opinions about how to implement it. So there's a lot of discussion when it comes to the entire supply chain. Um, and some of these discussions revolve around sustainability. I told you about the displacement of the batteries at the end of cycle. How do you do that? What would be the effects of it? And also the mining. Some of these mining is happening in very poor countries, in countries where there are conflicts and very serious social conditions. And sometimes the miners, the communities are heavily affected by these things. So how would that affect? So there's a lot of conversation, especially in the European Union, about how we ensure parity in this supply chain and ensure that that EV transition happens in a justifiable way. Now, for instance, one of the biggest challenges is if you take Congo, for example, Democratic Republic of Congo. It is one of the places where most of these minerals are mined. Uh, for instance, cobalt, nickel, and so on comes from Democratic Republic of Congo. But it has been reported that there's a lot of social injustices in this country. So if if a country in European Union is transitioning to be more sustainable by having electric vehicles, are you going to do that at the expense of creating some sort of an unjustifiable, unethical activity in Democratic Republic of Congo? So these conversations are also emerging in the general general forums that are there in electric vehicle manufacturing. So now there is even more Okay, sorry, I was experiencing a power cut, so I'll just reshare the slides. Okay, so I hope you can see the slides.
Yes, we can see, sir.
Yeah. So still we are having a power cut, so I'm just connected through my hotspot. So I might not be able to switch on the video until the power comes back on. It's a little dark here, but I'll continue where I left off. So when we talk about the supply chain, I think there's a lot of conversation about how we ensure that these technological enhancements and whatever practical elements, how do we really ensure that it is properly connected across the supply chain within these sustainable parameters? This is the real challenge that everyone seems to be worried about. And when you really take a deep dive, if you take that slide a little further, you will see that there's a lot of emphasis on the supporting supply chain that is there also. Now, when Sri Lanka, for instance, Sri Lanka had its first growth spurt of electric vehicles around 2015, 16, 17, when Nissan Leafs, primarily coming from Japan and the UK, hit the local market. And at that time, the prices were fairly low, and a lot of people actually bought them. But at that time, the charging infrastructure was essentially non-existent, and there were lots of uh, lapses in the overall fabric of regulations and all the other constraints that were there. Um, 8 years down the line, we are better off than we used to be. We have a charging infrastructure. The Ceylon Electricity Board has charging infrastructure. Companies like ChargeNet and so on have emerged. But there are certain loopholes in terms of battery replacement, cell replacement, and so on. Some companies do it. Some companies do it in proper way. Some others do it in an inappropriate way. There's no proper regulation. And essentially, there are certain challenges across the supply chain. So in essence, what we can really think about is that, in this instance, Sri Lanka did not have the right regulatory system or the infrastructure when we brought in the electric vehicles. And as a result of that, there have been certain challenges that our users have faced over time. It's a big challenge. And right now we are seeing the formulations of policies and so on, which is obviously helpful. But the problem here is that in spite of the emergence of such policies and so on, maybe another country somewhere else in the world will face similar outcomes. So that is the challenge. So from the perspective of the entire world, we need to understand that there are lots of unanswered questions with respect to how we make that transition to 100% electric vehicle market. It's not easy. It has a lot of pitfalls along the way. And one of the biggest challenges in this is what do we do with the battery? Now, I also own an electric vehicle, and this is a challenge that I'm supposed to overcome over the next maybe few months, right? Do I get it repaired? Do I get it repurposed? Do I sell my car to someone else, or do I get it remanufactured? Or I don't think I have the option of sending it to direct recycling in Sri Lanka. What is the process? So at the end of the life cycle, how do you really assure that the electric vehicle battery is put to good use, and it is not put out there in a hazardous manner? Because we all know the battery is very hazardous. It can explode. There can be so many problems. There are so many different regulations, international regulations that are there with respect to how to handle the battery, right? How to transport the battery. But how can we really manage the battery without violating any of those guidelines? So these are problems I think a lot of us have to answer and understand in the future. And I think some of these regulations are still being developed, and I will show you some of them in future slides. So I told you earlier about the critical minerals, and you can see that there is an area, you might have heard of this previously. There's an area in South America called the lithium triangle. The lithium triangle essentially covers, primarily it is in Bolivia, and apart from Bolivia, it covers certain sections of Chile and Argentina. I think probably the most renowned area among this is the Atacama Desert, and also there are salt plains in Bolivia. This is the area where majority of the world's lithium comes from, and the world map shows the flows of trade, and you can see even though majority of the lithium comes from the South American region, um, the value addition, the trade flow primarily happens around China, around Europe, and also to some extent in America. So without the lithium that comes from South America and other parts of the world, I don't think we can expect this level of electric mobility. The electrification of the fleet happens because of this lithium, because currently that is the primary source of energy. In the future, it can move to sodium, it can move to a different source. We don't know. There are a lot of experiments being done. Some of them have been successful. I think some people are predicting that sodium might take lithium's place, but we don't know when that is going to happen and how quickly that is going to happen. But the problem is right now, even if we transition to a different critical mineral, how do we ensure sufficient supply? Because in order to electrify the world's vehicle fleet, we need more and more uh, critical minerals. They have to go into being part of the electrolytes and so on. And then how do we ensure that that supply, that large quantity of supply that is required to manufacture the vehicles? That's number one. And number two, when it comes of, oftentimes it comes from impoverished countries or developing countries or sometimes conflicted countries. How do we assure that those countries and the people of these countries get a fair share in their supply chain? That social sustainability is a real problem. So in Bolivia, there is a lot of challenges that have been cited. Bolivia is a fairly poor country. Um, if I'm not mistaken, they are a country even below us in terms of economic prosperity and so on. So how do we assure that the Bolivian people get a fair share for their contributions in empowering the electric vehicles around the world? That is a question. How do we ensure that the Congolese people who provide nickel and cobalt and so on are provided with a good life? Currently in Congo, there are lots of conflicts, and these mines are controlled in some instances by gangs and various other groups, which is not very acceptable. So this is a real issue that is being discussed at various points. So this map actually shows a further exposition of the distribution of various critical minerals. In Sri Lanka, obviously, we have carbon, graphite, which is not in this map, but primarily we are looking at lithium, cobalt, copper, nickel, and manganese. And you can see a lot of deposits of these, especially cobalt, nickel, manganese comes from Africa, Congo, and surrounding countries. And we see lithium coming primarily from South America, but there are considerable deposits in the US and Canada. Canada has a fairly large deposit, and Australia has abundance of these critical minerals around their country, especially in the Western Australia and South Australia as well. So you have deposits around the world, but you can see that most of the mining really is happening in Africa and South America, which is raising some red flags with respect to sustainability. And we are seeing, the projections for 2025 and the status in 2020, and what is expected is that um, the ranking. This shows the rankings in terms of the contribution uh, from mining in the supply chain. So the interesting thing is China is ahead because China is still providing a large part of the supply chain, but they are consolidating its position. Um, so is Australia, but US is giving a major push because especially under the Biden administration, they've been pushing the electric vehicle transition. There's been a lot of pitfalls, but they have put tariffs and so on to discourage imports from China, and they are encouraging exports as much as possible from US. But the problem is the battery technology is not really picking up in US. There was a big issue in terms of establishing a cattle-backed Ford plant in US. One of the states that it was originally deemed to happen in, Virginia, did not want that battery plant. And eventually it has settled in Michigan, and still there's a lawsuit or two, I think, trying to sort of, you know, uh, discourage the possibility of having that sort of a battery plant in the US. So we are seeing these major shifts. So it's actually electric vehicle technology adoption is not really stopping at a point of being a technological or an innovation driven expansion. The quite interesting and intriguing thing is it has traversed into the domain of geopolitics and controlling different levels of the supply chain, different provisions within the supply chain, and it's not easy. So overall, I think a lot of challenges have been faced, and that's why I'm emphasizing in this slide that we have what we call uh, uh, we have political tax reductions or tariff reductions. So there were certain issues with respect to that. So that was a real challenge that was brought about, and I think at the end of the day, these affect EV adoption. One very famous example is how uh, Ford is an American brand, as you know, and they have a very rich history. Some years ago, they did one of their most you know highest selling models is the Ford F-150 truck. Well, in Sri Lankan terms, you would usually call that a double cab or a cab, but Americans call it a truck. So the F-150, it is essentially a gasoline powered vehicle, but several years ago, Ford took this measure to make an electric version of the F-150. They called it the Lightning. Um, but sales never picked up to the same level they wanted, and as a result they had to reduce the production volumes until the battery technology was brought to the US. So there are challenges like that which really influence the adoption. So that is a big issue that many of these manufacturers are facing right now. um, so subsidies and protectionist policies, for instance, US is quite protectionist of their industry, and they're trying to sort of ward off other manufacturers like BYD and so on coming into the US market. I think some of them have even sued against these regulations. So the focus is trying to sort of stop um, Chinese infiltrating the market, and they're trying to bring down the government essentially wants to have 100% American battery manufacturing, uh, which is in the works, but long way behind. But at the same time, cattle has interest in manufacturing in US and in the European Union also. A lot of these manufacturers in the European Union uh, are changing into electric vehicles, and now they are relying on cattle for manufacturing. And I think cattle already has a factory in Germany, in the state of Thuringia in Erfurt, and they are planning, or if not, they have already started plant in Hungary, close to Slovakia. In Slovakia, they have a lot of manufacturing happening also for cars. So you are seeing a lot of these large markets trying to attract manufacturers like cattle to come in through various subsidies and various policies, so that part of the supply chain moves to US as well as to Europe. And primarily, obviously their secondary goal is to attract Chinese industries to US and the European Union, but their primary focus is to develop their own brands and to develop their own companies to build these technologies, which is not easy. So you're seeing a lot of that, and also you're seeing high production costs. Especially now, if, for example, the German government, I can't remember the exact number, but German government last year issued that they have a subsidy for electric vehicle purchases. The government gives a certain amount of money for anyone who's buying an electric vehicle. So that basically meant that the government has lost a lot of money to ensure that the electric vehicle is competitive in terms of price against the gasoline, the ICE vehicle. It doesn't happen that easily because of the cost of the battery. So because the battery is expensive, because the battery has scarcity of the critical minerals that are required, the production cost is still a little more expensive than ICE, and it is expected to go down with new technologies that will come in, like the blade battery, like the LFP and so on, and maybe switching into other industries. Maybe sodium might, one of the arguments for sodium is that sodium might be more abundantly available than, let's say, lithium. So we don't know, but in the future it might come down. But at this particular point, an electric vehicle is considered to be more expensive as opposed to ICE vehicle. The infrastructure challenges are quite pertinent, especially in some parts of the world. It's very serious. In some parts of the world, it's not that serious. Even in a country like Sri Lanka, we see that given the number of electric vehicles that are on the road, we have a fairly decent electric charging grid. CEB has certain stations, ChargeNet has certain stations, and there are other service providers that are providing electric vehicle. So, but obviously there's a lot of other room to improve as well. If you go to European countries, you see that there's a lot of support to develop infrastructure. Even in UK, you see that. So there are lots of you know, how do I say this, support that is there, but still it is not at the optimal and ideal point. You need to get the entire supply chain to work together, from the repairing people, the charging stations, to the technicians, to the after sales service, servicing, and so many different things that need to come in to support the users. And also you have regulatory differences. So even starting from the charging topology to the transportation, the safety guidelines that are there, to the connectors, the various components that are there, it is different. For example, you might have like this would be the traditional charging topology that is used in a Leaf or something, but Tesla has a different charging topology. Sometimes you may have to use a connector to use a charging dock there. Uh, and there are some challenges to bring everyone to a uniform standard. It's not going to happen overnight. It might encounter some problems. So there are certain teething issues to look at. And I think one of the real issues I think we need to really tackle is the fact that transporting minerals is one thing, but once you make the battery, transporting the battery, which is also a hazardous product, is not easy. And the United Nations has stepped in, and they have intervened in this entire discussion by bringing together various people. So through different expert panels, through opinion discussions, through decisions, um, they have influenced non-government organizations, international organizations, through various policies to ensure that there can be some level of transporting these batteries. So I told you that 40% of the value of an EV is essentially developed based on the battery. And one of the reasons the battery is high is there are many reasons. One reason is the scarcity of the critical minerals. The second one is the technology. And another one reason is the expenses that are incurred in terms of the transportation. Because if you manufacture a battery in China, it might not be so easy to bring that battery from China to um, Sri Lanka or UK as if you were bringing a tire or any other car component. There are lots of other hassles you need to go through given the fact that it is a hazardous material. So the United Nations has enforced certain regulations, especially to ensure that these are properly transported and they are properly controlled. And there are various other international standards that have been brought about uh, by various entities, including IEEE. IEEE standards are more to do with cellular telephone batteries and computing devices and so on, not particularly to the electric vehicles as per my understanding. But all of these standards need to be met in order to transport batteries, and especially for lithium-ion batteries, there are 8 tests that are recommended by the United Nations um, that need to be conducted before the transportation happens. The altitude simulation, what happens if the altitude changes, thermal testing, because if the temperature goes up or down, let's say it is airlifted and it goes through Dubai or Abu Dhabi or Qatar, where the temperature is high, does it mean that there would be a problem that may occur? Would vibration create a problem, whether shock would create a problem? So all of these different types of tests must be conducted before they are approved for transportation. So there's a lot of regulations with respect to transportation of the batteries from A to B. And without that, I think we cannot bring down the cost of batteries. And without bringing down the cost of batteries, we can't bring down the cost of EVs. And then only can we actually try to promote EVs among the people. So now the UN has various standards for everything. The standard for general batteries is 38.3, UN 38.3, but 38.8 is the standard for particularly for EV batteries, lithium-ion batteries that are there, which are larger batteries, which is combining different cells and cell packs together. So if you are transporting, let's say, phone batteries, you would only subscribe to 38.3. But when you're transporting EV batteries, you have to conform to 38.3, but you have to go beyond that and conform to 38.8 as well. And without that confirmation, it's very difficult for anyone to transport EVs. And that transportation will be multimodal and across the entire supply chain from A to B. So supply chain, some of you might not be familiar with the term supply chain. Maybe I should have started by explaining that. Supply chain is essentially ensuring the movement of 3 things: movement of information, materials, and money in a very seamless manner. So if you take the electric vehicle battery, the EV battery supply chain is essentially ensuring the raw materials are brought to the manufacturing locations, the refining locations, the processing locations safely, transformed safely to the battery, and then it is moved to the production plant, and then from there the assembled car is safely transported to the consumer. That entire coverage is within the supply chain, and under that, all the matters related to material handling, all the matters related to information flow, and all the matters related to the monetary flow is part and parcel of the supply chain. So what happens within that in terms of the battery manufacturing, how the technologies that you use that within that is different. There might be electrical engineering, mechanical engineering, chemical engineering applications there, but the overall process handling is the supply chain. So when it comes to ensuring that the end-to-end supply chain of the electric battery from the mines of Bolivia or Democratic Republic of Congo or Australia or far northern Canada, going to the battery manufacturing plant in Fujian in China, coming to the vehicle purchase in, let's say, in India or in Germany or Norway, for example, all of that, the transportation, the handling within all of that entire journey from the cradle to the grave, we call it the cradle to the grave. Cradle would be where the raw material is sourced, the preliminary primary raw material. Grave is where we discard the product. It has to come under the supervision of the UN 38.3 and 38.8 guidelines. So that is something a lot of organizations are struggling to work with, given that it is a hazardous material, and you need to sort of develop technology, and you need to work over time, because now, for example, you can't ship too many batteries on the same container, because it might be a recipe for disaster. And obviously, you know that they are considerably heavy also. So there are lots of challenges that you need to overcome to circumvent this problem. So as a result, I think one of the challenges we have is how the electric vehicle supply chain, uh, can be managed in a clear way, and how and where can you make an impact. And that's, I think, a very serious question we need to really think about as young professionals. You need to think about how you can make an impact in different points of the supply chain, because if you look at the overall EV supply chain, I think none of them has reached a level of maturity. In all of these points, there are areas for you to contribute. And I think electric vehicle battery supply chain is a very multidisciplinary field. So if you take engineering professionals alone, you can think of how many different engineering professionals are required to make this tick, right? You need earth resource engineers, mining engineers, you need electrical engineers, you need chemical engineers, you need electronics engineers, computer science engineers, you need logistics and supply chain engineers. You need a whole gamut of different people of different background to contribute at different levels. And it's not just engineering professions, it's also maybe marketing professionals, economists, and various other people. So for example, if you have a very good vehicle but you can't sell it, it's a problem. So you may need good marketeers to do that. You may need good policymakers to support those sorts of initiatives, to promote electric vehicle usage. Now in US, that is one of the challenges that is there. Some policymakers are not fond of shifting towards electric vehicles, because they don't want to move out of that gas-based economy. So how do you influence that? So you need to have a very wide discussion where you bring in stakeholders from different backgrounds and work together to promote the electric vehicle adoption. And in that journey, I think everyone has a role to play, and you need to understand where you fit in, where you can support that endeavor. So for me, I feel my contribution is from a supply chain angle, because I'm from the transport management and logistics engineering department of University of Moratuwa, and supply chain is my expertise. So I'm not an expert on chemical engineering to say, what elements can be used, how we can contribute better. Um, I'm not an electrical engineer. I'm not a earth resource engineer or a mining engineer to say how best we can extract the minerals from a particular mine and how best we can process them or refine them. So everyone will have their own contribution, I think, in the grand scheme of things when it comes to EV battery supply chains. So let me just explain some of the opportunities I think we have as Sri Lanka. And I think one of the biggest examples for us, I think, is the fact that if you look at the world map, uh, we are very well positioned in Asia. And you are aware that India is the largest economy. India has the largest population in the world right now. They overtook China, I think, about last year. So we are actually next door to the largest market in the world. So we might not be the best place to set up a battery manufacturing plant or a car manufacturing plant, but we might be able to provide an entry point to the Indian market. And we all know that there is a little bit of a grudge between India and China politically. So, but Sri Lanka is generally a neutral country, and we work with Indian investors, Indian companies, with Chinese companies, Chinese investors. So there's a possibility that we can, use our market proximity both to India and to some degree to China, and the fact that we are in between Africa and China also to create some opportunities in terms of industrial development. And we have pure graphite deposits. There are well-reputed companies like Bogle Graphite. Bogle Graphite is actually doing a lot of innovative things. Uh, you'd be sometimes surprised because it has actually moved on tremendously from what we have actually thought of graphite mining. They have very high-end products also. So the anode of the battery, which is carbon-based, we can actually contribute through the graphite deposits in Sri Lanka. But there are some relaxations of the regulations that need to happen because sometimes there are lots of untapped mine deposits of graphite in Sri Lanka, but some of these regulations need to be relaxed to support those mining, processing, and refining. And obviously, I think we have very talented human resources. We have some best engineers, best technicians, very good humans that are able to work very diligently. And I think that's a very rare resource that Sri Lanka has to use. And I think hopefully if we put it to proper use, there will be a lot of opportunities. Then around the world, there are lots of focus on sustainability. And especially in the European Union, they are bringing laws like supply chain due diligence laws. Supply chain due diligence laws means that anything that is happening in the supply chain needs to be properly reported, especially environmental impact and social impact. So whatever the emissions that are taking place, whatever the salary is paid, whatever the financial costs, you need to explain. That is not easy, it is challenging, but Sri Lanka generally has a better track record than many other countries in terms of due diligence, in terms of sustainability. Especially our apparel industry is considered to be having very good practices compared to the rest of the Asian region. And also in some other industries like tea, for example, some companies have shown immense success in terms of sustainability. So if with that approach, with those learnings, I think there's a possibility for Sri Lanka to make an impact. And I think one area that we rarely touch upon is the RoRo hub. You might be confused what I mean by RoRo. RoRo is roll on, roll off. Roll on, roll off is a type of vessel. Maybe I should have put a picture of this there. Sometimes you might see these very, very nice looking carrier vessels. They are very different to container ships. They are vessels, ships that carry cars, and within that, it's like a 5 or 6 story car park. You have cars that are lashed into the vessel, and they go from car manufacturing countries to where people are buying cars. And Hambantota is a ro-ro hub. It has 98% of the vehicle movements in Hambantota happen as transshipments. Transshipment means it comes from one country So it takes one vessel. So let's say there is a vessel coming from China that goes to let's say Europe, right? So they will unload the cars. Maybe let's say 100 BYD cars will be unloaded in Hambantota, and the vessel will continue to Europe. Maybe there's another vessel coming from, let's say, Europe that goes to Australia, that goes to Sydney. They will pick up those 100 cars from Hambantota and take it to um, Australia. So this makes it a very nice place for value addition. So some of these things in the manufacturing value addition and so on can happen in Hambantota if necessary. So I don't know. Hopefully, people will look at it and it will provide some opportunities in terms of being part of the overall supply chain. But at the same time, we have several challenges in Sri Lanka. So one challenge is regulations. We need to come up with proper regulation, both locally for using electric vehicles as well as for manufacturing electric vehicles and its components. We already have certain small companies which are manufacturing golf carts, scooties, small things, and you know the innovations of Vega. You have seen them. So you have certain players which are manufacturing starting from components going up until large vehicles. And in Sri Lanka and University of Moratuwa, we have a very good example at mechanical engineering department with their Formula E vehicles. So we can do it, but there needs to be some regulatory support. And of course, most of those have been prototyped, but there are success stories in terms of golf cart exports and so on that are very successful. So the regulatory barriers need to be relaxed for those. The technical expertise, I said we have good talent, but we need to improve that technical expertise. Our people need to know those technologies inside out. We need to train our people. We need to have more technicians who can work on electric vehicles. So that is a challenge. And I appreciate what you guys are doing through this particular program, the workshop series, to provide that insight to the young generation. And obviously, we need to bring in more investments. That investment can come locally or internationally. So some of these investments can be local. Some of these investments can be brought from other investors around the world. But if we can do that, it will make a big step. And another major issue is, of course, I told you about carbon being abundantly available in Sri Lanka, but we don't have lithium. At least we don't have known deposits of lithium. And other critical minerals such as nickel, cobalt, manganese, and so on, we don't have them. So that is a challenge that we have to attract supply chain, or rather more manufacturing businesses. But that doesn't mean that we can't bring in supply chain players, so that we can bring in those materials from all around the world and put it together and provide components or different parts that we can export to the rest of the world. I mean, this is nothing new. If you take Singapore, for example, Singapore is very famous for that. It's a very small city state, and as a city state, they don't have a lot of resources, but they bring resources from all around, and they do the processing, they do the refining, they do the manufacturing, and they sell it to other neighboring countries. And I think if we really put our heart into it, Sri Lanka has that possibility. I showed you in the previous slide. So that's it. I'm sorry that we had a small disconnection because I had a power cut here at home. But if you do have any questions or anything that you want to follow up with, I'm more than happy to answer.
Thank you, Professor, for that informative session. your insights have truly added depth to our participants' understanding of the EV battery supply chain, the challenges of ensuring sustainability. I believe the foundation you have led today will surely help our participants in their academic or professional journey. As we move forward, we'd like to open the floor for a Q&A session. We invite you to raise any questions or doubts you may have about the content that we discussed today. You may raise your hand and I will call out your name. Then you may unmute and direct your questions about the keynote speech to Professor Niles Perera, or you may use the Zoom chat to ask questions and I will read out to our speaker. Yeah, I think we have a question in the chat. So there is a question for you. Could you please tell us more about how we can use our graphite resources in the country to improve the economic status of Sri Lanka other than exporting of the raw material?
Yeah, so I think one of the things we need to understand is, I mean, there is a common idea that most of it is exported in raw form. But I know for a fact that there are certain companies, like for example, Vogel Graphite, that do considerable value additions in terms of exporting uh, certain very bespoke products. So, I mean, what we really need to do is to try to enhance that. That is one thing. And I think also one of the challenges we have is our unit production costs are considerably higher, I think, in some markets related to graphite resources. That is because of various regulatory challenges due to certain regulations that are there. So I think this is probably something that needs to be looked at in the future. But of course, I'm not an expert in the entire graphite supply chain. So to my understanding, what I feel is that we need to understand, we need to sort of provide certain supports that are required by the industry. When I have spoken to and listened to some of the industry leaders, they seem to be aware of some of these market opportunities, and in some instances, they are taking advantage of these market opportunities. But of course, further support, both at local level and at international level, would be useful. If we tag that into the battery supply chain, I think one of the challenges we have is we are far away from, we are actually quite far away from China, and China has much more closer sources for carbon for their anodes. So for them, it doesn't make a lot of sense for them to procure directly from Sri Lanka, because even in China, they have carbon deposits. But maybe in the future, I feel if we are in a position to sort of tap into the Indian market, we might have a better opportunity. I don't know. I mean, I might be a little too optimistic, but I feel that maybe a company like Cattle or anyone who might want to move into the Indian market might find Sri Lanka a better place to at least source some of the materials. Even if they don't do the manufacturing in Sri Lanka, they go and do the manufacturing in India. They can still source some of these graphite from Sri Lanka. So there is that possibility. So yes, I think those might be the opportunities that we can use.
Okay, thank you very much for answering that question, sir. I encourage all the participants to take the maximum out of this opportunity, ask questions and clarify your doubts. Any other questions? Let's take another few seconds. Do you have any questions? Either unmute yourself or use the Zoom chat to ask your questions. Okay, I believe that's all the questions we have from the audience. Thank you, Professor, for answering and clearing their doubts. Moving on,
My pleasure.
Yeah, thank you, Answer. Moving on, we would like to express our gratitude to our esteemed speaker, Professor Niles Perera, for accepting our invitation and sharing his valuable knowledge and expertise with us today. Please accept our token of appreciation, sir. Your presence here has set a high standard for the caliber of learning that we can expect from this workshop series. Thank you once again, sir.
Thank you very much. And thank you for the entire organizing committee for inviting me. And it has been a privilege to be a speaker in the workshop series. I'm sharing my email address also in the group chat. So in case anyone has a follow-up question, if you remember something you should have probably asked, maybe in the evening or anytime, just feel free to drop me an email and be happy to answer.
Thank you very much, sir. Before proceeding, let's take a group photo to remember this valuable time we spent learning together today. I kindly request the audience and the OC members to switch on your cameras to take a group photo. Let's wait another few seconds till everyone is ready. All right, everyone, get ready. On the count of 3, I'll give you a cue to smile and pause. 1, 2, 3, say cheese. Okay, thank you very much. I think we have captured a good shot. Thank you all. Also, please note that the quiz will be conducted on the 5th of October at the end of this workshop series. We have now shared the feedback form in the chat, and you can scan the QR code as well. Your feedback is extremely important to us as it helps us to continuously improve and provide you with a better experience. This is also considered for your attendance as well. We will share in the link in the WhatsApp group as well. Moving on, the next session will be on next week, 14th of September from 5 p.m. onwards, where Professor Shin Song-Hu, Department of Automotive Engineering, Chongqing University, China, will join us to take you through the battery system management part 2. As we near the end of the session, we sincerely hope that you found the workshop informative and that you have with new insights and ideas. And with that, we conclude today's workshop. Thank you once again and have a good night.